in trigonometry, there are situations that you can still solve triangles, solve for all the missing parts, if you don't have a right triangle. And law of sines is one of those scenarios that allows us to do that. Law of sines is a, move this guy just a little bit. Law of sines is used when you don't have a right triangle and we'll get there in a second. And the way that this works, it kind of goes into a excuse me, kind of goes into the old mode of angles and sides opposite, just like we have been doing. When you have law of sines, you're going to have your three angles. In this case, I have written as angles A, B, and C. Remember, angles always have capital letters, which means that the sides opposite them are going to have what? They will have lowercase letters. Remember that? Sides opposite angles have the small letters. What we say then is opposite angle A would be little a. Opposite angle B is little b. Opposite angle C is little c. And this whole idea of this thing called law of sines is just going to be ratios. And remember, ratios are just fractions that are set equal to each other. And we talk about it in terms of the sine of an angle to its side opposite. And it looks like this. The sine of angle A is to the side opposite, as the sine of angle B is to its side opposite, or the sine of angle C is to its side opposite. Now, obviously, when you're solving equations, you don't normally have two separate equal signs. What that means is that you're going to be using two out of those three parts to solve the problem. We use law of sines when you have an angle and its side opposite. That's kind of the thing. If you have an angle and its side opposite, when you know an angle and its side opposite, it looks, I don't know if you guys have ever seen this before, it looks really weird, but it's super easy to use. Super easy to use. Sine of A is to its side opposite. Sine of B is to its side opposite. Sine of C is to its side opposite. I'll put it over here too so you guys can see. I'm going to get a new marker. And just like what we've done in the past, what we're going to wind up with is we'll have an angle and a side opposite, and then we'll know a side or we'll know another angle, which will allow us to find another angle, find another side. How many degrees are in a triangle? 180. Then we might have to use this twice. It's a very, very easy thing to use, but you just have to remember that the sign of 17 is just some crappy decimal, and you just have to be able to write it out in order to press buttons. Right? Let me show you an example. That's the easiest thing to do. Let's say we have this triangle ABC, and we have two angles and one side. And in this case, I just want to find side A to start. And then we'll build into what you have to do to find everything. Excuse me. Oh, the allergies are kicking today. I guess that's what happens when it's 50 degrees out. We have triangle ABC. We've got, like I said, angle A, and we have angle B, and we have side opposite angle B. That's lovely. What I like to do a lot of times when I'm first learning and first using this thing called law of sines is I like to circle. Try this again. There we go. What I like to do is circle the information that I have that has an angle and a side opposite. The reason I do that is because then I know how to set up my first ratio. I have angle B and its side opposite, so what I do is I write it out. I'm going to say the sine of B is to its side. And what other angle am I given? A. So I'll write out that ratio. Sine of A is to its side opposite. I fill in the blanks. And once again, it's just cross multiplying itself. What happens here, though, is that you're either going to have to find an angle or you're going to have to find a side. In this case, what are we trying to solve for? A side. So I'm going to show you guys kind of what happens, and then you'll probably be able to figure out a little shortcut here and maybe one or two examples. Whenever you have fraction equal fraction, you solve it by cross multiplying. You guys okay with me on that? Remember, we've done that 1,000 times now. So if I cross multiply this, I'm going to get A times the sine of 48 equals 28 times the sine of 35. I'm leaving it written out in terms of that word sign there. Because remember, it just means it's just some crummy decimal. And that way I don't have to press all the buttons and keep writing decimals down. This is cleaner. So on the left, how do you undo multiplying by a crummy decimal? What would you do? Divide by the crummy decimal. So in order to move this back, and this is what I put in my calculator. And that's why I write it out that way, because now I have a fraction bar and everything. All I do is just type in the calculator like I would normally. Yeah, because then A will equal, because what's some crummy decimal divided by itself? It just becomes 1, yeah. So in the calculator, let's see here. So let's see it. Remember, make a fraction bar. I type in 28 sine of, what was it, 35 over sine 48. And it looks exactly like what I wrote. And what do I press? Enter. And there's side A. It's quite literally setting up a cross multiplying. And when you do that, round 2 decimal places, and you get 2161. You got an email. Okay. Yeah, there's not a lot of trickery here. Tomfoolery or anything. Don't get me wrong. When we get to it, when we get going in a minute or two here, I'm going to show you a couple ways of doing this. We're going to add the next step, which is just find the rest of the triangle, which, again, works out to be pretty simple because it's the same setup. Let's try the other version. I want to find it. Yeah, I want to set up this one. The other scenario for law of sines is sometimes you have to find an angle first. Sometimes you have to find an angle. No, ABC, PQR doesn't matter. It's just the side and the side opposite. The answer is angle and the side opposite. So angle P has little p across. Angle Q has little q across, and so on and so on. I want to make sure you saw that as well, because sometimes they change letters. It just remember it's angle and the opposite. What is this forcing you to find first? Yes, sir. What smaller one? What's it trying to, what is it trying to get me to find? Jack? Big cube, right. It's making me find because we already have this, the angle and its side opposite, which means I'm trying to find this angle first. That's kind of what you're looking to be able to do here, guys. You're looking at the problem after you draw it out. What information do you have? In this case, we have the angle and the side opposite. So I know I'm going to use that. The sine of 33 is to its side opposite, is to sine of Q to its side opposite. Right. And then remember, what buttons do you have to press to find an angle? Inverse. That doesn't change. This is actually about one step less than the one we just did. Because if you look at it, you have sine of angle Q divided by 40, which means I have to move that divided by 40. How do you undo divide? Multiply. So what we do is we multiply the 40 over. We get 40 times the sine 33 divided by 27 is the sine of angle Q. If we've done this problem 100 times so far in the past 2 weeks, don't get worried, Spots. You've done this. You have some crummy decimal equals the sine of an angle. What buttons do you have to press? Inverses. All we have to do is the same thing we've been working on over and over, guys. We type in the junk on the left. Fraction bar. 40 sine 33 over 27. Hey, look, it's a crummy decimal again. Some crummy decimal equals the sine of an angle. How do you undo the sine? Well, remember, second sine of my answer. Remember how many times we've done that so far? When you had to find angles with right triangles? Same thing. It's the same process. It just so happens that it's all sines as opposed to, oh, what was the cosine? Okay. Inverse sine of your answer. There's your angle, 53.79. That's what law of sines allows you to do. It allows you to find missing angles and missing sides if you have a side and its angle opposite. Yes, ma'am. Huh? Second answer. It's the equal button, the bottom right, I believe. Or not equal, I'm sorry, it's the negative. That should be your best friend. You should use it all the time. That way you don't have to write out all the decimals. This is quite literally a ton of calculator work. It's quick setups, doesn't change, and then just pressing some buttons and get some angles and sides. All right. So let's see what we get. 53.79. So those are the two setups that you'd have to have, whether you're cross multiplying the whole thing or you're just moving up to one side and taking the inverse to find an angle. But after you use law of sine once, you'll notice then how many angles will you have out of the triangle? We have 2 of them. How many degrees are total in a triangle? 180. How would you find the third angle in this case? We just subtract, right? I know that if I have a 33 and I have a 53.79, if I take my calculator, subtract out those 2 angles, how many degrees the left angle are in this case? And then now you have an angle, you got to find the side opposite. You would use law of sine one more time to find the other side. It just keeps these problems. You have to do like 2 parts to it because you can use it to find all the parts. Right. So let's see here. 180. Subtract out the 33. Subtract out the 53. Excuse me. 97. And that gives me. And just like we did a second ago, we set it up again to find little r. Sine 33. Flattening out is going to make it r. When you're using law of sines, yes, it looks really weird because there's a lot of writing here, but the actual math of it is really, really easy. Okay? It's just a matter of keeping your sides and your angles opposite one another and straight. Yeah. Yep. Always use what you started with to find the other parts. You'll get a lot less rounding error through like that. So we would cross multiply like we did the problem earlier. R times the sine of 33 is 27 sine. And then you just divide out. Remember, guys, the value where it says sine of 33 is just some crummy decimal that your calculator will do the work for. Yes, sir.
So when it's not a right triangle,
Yeah, we'll use log sines. I don't think we'll have time this year to talk about the thing called log cosines, because that's a whole other scenario. I'm just going to keep with log sines. Yes, ma'am. Cross multiply. Oh, I divided. Remember, sine of 33 is just some number. How do you undo multiplying? If it was 3 times r, how do you undo multiplying by 3? This is just have to be the sine of 33 times r. So how do you undo multiplying by sine of 33? You divide by the sine of 33. Don't get hung up on the fact that it says sine. Remember, it's just, if you split it, just press your button real quick and put your pen down. Put your pen down. Type in your calculator sine of 33 and hit enter. That's just some crappy decimal. Do you want to write all those numbers out? No, just write it. Need this sine of 33. It just means it's just a crummy decimal. That's all you have to worry about. So how do you undo multiplying by crummy decimal? You divide by crummy decimal. And that's where I'm getting at. Trust your calculator, trust yourself. So let's see, 27 sine 93.21 divided by sine of 33. Did you guys get 49.50? There you go. Josh, do you have a question? And honestly, really, what's different about law of sines versus when we had right triangle stuff? When you had right triangles, you knew that the Pythagorean theorem would always work. We always knew that with the right triangle stuff, you could always verify with the Pythagorean theorem. With law of sines, it's kind of hard to make sure that you're definitely on the right track or definitely correct. The best thing that you can do is just kind of check if you have the largest angles across from the longest side length, shortest, and so on and so on. That's really the downfall of law of sines. It's kind of hard to verify. So my biggest angle here was 93 something. My biggest side was 49. That works. The smallest angle has the smallest side and so on. Okay. It's one of those weird things that happens in math that can't always double check yourself. All right, let's try another one. Move this over a little bit here. So we have triangle ABC, and you have side C and angle C, and you have side B. Which means, what is it forcing you to find first? B. Very good. It's making you find angle B. Everybody see that? Since you've got the side opposite, that means you've got to find its angle. So just like we did earlier, when I start these out, I really like doing this where I just circle what I'm given with the angle and its side opposite, because then I'll just reuse that a couple of times. So I start writing it down. I know that the sine of 16 over 11 is the sine of B over 12. I have to undo divide by 12, and how do you undo divide by 12? Multiply by 12. So I just rewrite 12 sine of 16 over 11 is, and now I'm at a point where the rest of the problem is pressing buttons. The rest of the problem is pressing buttons. Fraction bar, 12 sine 16 over 11, and I hit enter. I get 0.300695, blah, 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 blah. Are we okay with that? Now, that decimal equals the sine of an angle. How do I find the angle from that? Inverse. Yep. Second sine of my answer, I get 17.5. Ms. Rosswood, you looked up rather quickly, went, I got 17.4999, 499, so it would be 17.50. Did you not get that? So what do you think?
Okay, so that's just the decimal part, so then you have to take the inverse, so you have to do inverse of your answer, and then you would have gotten it. Okay.
I'm sorry, what? It depends on what the topic is. So in this case, I had to get the angle. The other one I had to get the side. This is finding the angle. All right, so you're here. So inverse sine of your answer. Remember, at this point here, you got some blah, 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 blah equals the sine of b. So what we did was we took the inverse of that junky decimal. I'll put decimal of junk, point junk. And that gave us our angle. That's what we're just doing in the calculator. Okay? And I just wasn't writing it through. Excuse me. That gives us, what, 17.5 for B. Now, how do we figure out what angle A is? What's that? Very good. Remember, when you have two angles of a triangle, the third angle will just be 180 subtract the other two. So if I take 180, subtract 16, subtract 17.5, I get, very good. So now I have the angle A at 146.5. And now to find little a, I'm going to use the law of sines one more time. In this case, I'm using this, I'm finding the side length, so it's a little bit different from the dividing, like we were saying. Let me just do that one more time. The sine of 16 is to 11 as the sine of 146.5 is to little a. So when you go to find your side length, you do a full cross multiply. Okay, we do a full cross multiply. Oops. And then it's, remember, it's 8 times the sine of 16. How do you undo multiplying by the sine of a number? You would divide by the sine of that number. Remember, guys, the sine value here is just some crummy decimal. And we're not writing out crummy decimals. And then this is what I put in my calculator. So 11 sine 146.5 over sine of 16. 2203. There you go. Go back up here. And once again, really the only thing that we can check Does the largest side length have has the biggest angle, and so on and so on. Really all you can do with these. Men, looks weird, but it's all procedural. Not always will you be given the triangle to start with, which means you have to draw it. Draw it, fill in the blanks, and then decide what parts do you have to find. I remember how we did this with right triangles. After we wrote things out, after a while, then we said, hey, we need to find AB, AC, angle B. It's not a bad idea to make after you draw your triangle, to write down the parts that you in fact need to find, because that way make sure you don't miss one. So if we draw this out, ABC, I probably should say, actually I didn't tell you what the middle letter was, but we can go ahead and call it B, right? So let's see here. So little c is 4, little a is 21, angle A is 55. Do you have an angle and its side opposite? Where? At angle A, good. So I'm just going to do this right away. What are the 3 things it's asking you to find? C. Are they angles or sides? Little b, big B, and then angle C. That's it, yeah. So we went and find angle C, angle B, and then little b. It's not a bad idea to make a list that we don't accidentally forget one. Law of science, it's very easy to think that you're done, but yet you forgot to find that 3rd angle. Something silly like that. In this problem here, what is it forcing you to find first? C, yeah, it's forcing you to find C first because it gives you the side opposite. So you write it out. We're going to use the sine of 55 is 221 as the sine of C is 4. What do I do first? Cross multiply. Good. Now remember, when you're finding the angle, I don't have to move that 21 because then I'd have to move it back. So whenever I'm trying to find the angle, I only have to do one version of the cross multiply. I just have to move the 4. Okay? Because if I move the 21, I'll get 4 times the sine of 55 equals 21 times the sine of C, which means I have to divide by the 21 to bring it back. So it's just an extra step. So we're going to get 4 sine of 55 divided by 21 is the sine of angle C. Means we have to press some buttons. Four sine 55 divided by 21. Before I do my inverse, everybody getting 0.156? Okay. Now to get the angle, this is when we have to do our second sine of the answer. And we get 8.98. Okay with that? Right, when I round up to 2 decimals. An inverse sign. Because you're trying to find the angle, because at this point, remember, you've got, at this point here, this was that 20 decimal of 0.156, blah, 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 equals the sine of C. That's when you did the inverse, okay? So we're doing the inverse of whatever the decimal jump is being, so I have angle C at, bless you, 8.98. You okay with that? What's that, bud? Yeah, I got a worksheet for this stuff too. There's a lot of stuff in the book that I don't like. Yes, sir. What? Yeah, yeah. When I get here, remember your if I use, actually, let me just open up the other. So your calculator. Night flies. Yes, sir. Yeah, just look at a couple minutes. When you're doing this, remember you have your fraction bar, and we have what? 4 sine 55 over 21. Hit enter, you got crummy decimal. Second sine of your answer gives you an angle. Okay. And yes, it was a little crummy. Now, on these, I just want to try a couple to start with. Your ratings. You're in the wrong mode. Your mode on your calculator, it should say that upper right corner should say degree DEG. Do these on a separate sheet. I just want you to do numbers 1 and 2. I just want you to do 2 of them to try out for right now, okay? And it says solve the triangle, which means you're going to solve for all the missing parts. You're going to find either 2 angles in a side, or 2 sides, or 2 angles. I'm sorry, 2 angles in a side, or 2 sides in an angle. Just do 1 and 2. Draw the triangle and work yourselves through, and we'll continue on with this more of this manana. All right. Is it working out, Cal? Yeah. And anytime you start seeing you get these little negative answers, it means you're in the wrong mode. All right. Thanks, guys. If there were spares, you can just leave them in the back. I'll get them after this. I'm sorry, what? If you draw it out, you can find how you find any way. You got A, B, C. How many degrees are in a triangle? You know what I'm saying? Don't overthink it. Once you draw the diagram, you go to the place real quick. We talk about using the old trig tables. Oh God, jeez, that was awful. Especially when you did stuff like this. Oh man, it was